Okay, I would like us to work on this lab together. So this is a lab 700, which is series circuit voltage. And we have some objectives here. We want to be able to calculate the electrical values in a series circuit using Ohm's law, evaluate volts and ohms of a series circuit, measure that voltage, and we're going to be doing that virtually in some software. And we want to explain changing resistance in a series circuit and how it has an effect on the circuit. Okay, so we're going to first, if you remember, for labs, these are all based on your instructor's evaluation and the way you answer it on Inside Rankin. Okay, so here, normally we'd be doing with a prototype board, a multimeter, some resistor kits, but we're actually going to be doing it in the Every Circuit software today. So here is our first circuit that we're going to be messing with. It's going to have 3 resistors, and I give you the actual quantities down here. And so we're going to start actually filling out our table, and I just put these here for your reference. The Ohm's law triangle and Watt's law triangle. Of course, you can use your Ohm's wheel sheet to do this as well. So first thing we want to do is fill out this table. Now remember, we start off with calculations. So we're not doing anything. Normally, if we were doing this in class, we wouldn't have a prototype board present for this. We wouldn't need to build anything yet. We're just calculating out what our theoretical circuit is going to be. So I'm just going to start taking my givens here and filling them into my circuit here, my table. And so I know I have 10 volts there, okay? And then here I have 1.1 k ohms for R1. So if I just come R1 over here and 2 K and ohms, it is Alt 234 if you're actually typing this in for omega. Okay, and then here I have the same thing, so I'm just going to cut and paste that. Okay, and then here is 3.3 K omega. Okay, so now what I want to do is find my total resistance, and remember, total resistance is additive. So if I take 1.2 plus 1.2 plus 3.3, 2 plus 2 is 4 plus 3 is 7, okay, and 3, 4, 5, 5.7 K. I'm going to come down here and say 5.7 K, and that is my total resistance. Okay, so now I can use that and actually calculate my current. Okay, so if I use my 10 volts, move this over here so you can see. Here's my 10 volts, and I divide it by, see, I equals E divided by R. So if you just cover up that I, you can see that it's E divided by R. We have 10 volts, and we want to divide that by 5.7 K ohms. Now, you can use your calculator, and you have the benefit of engineering notation on your calculator. I actually have to type in 5.7 as 5,700. And then I'm going to get a value that I'll have to convert back over to milliamps. But this is my actual quantity. So I want to move this decimal point over 1, 2, 3 positions to the right, and that's going to make it milli. So I'm going to have here, what was it, 1.754 milliamps. Okay, so since that is my total current for the circuit, remember that same current is common in a series circuit, is going to be going through this resistor, and this resistor. So I can actually copy this and put it on all of these. Okay, same current. Okay, so now we can see the dominoes are really going to start falling here. I know two quantities in each row. As soon as I know two quantities, I can actually calculate the third, in this case, voltage and also power. Okay, so what I'm going to do is I'm going to go just I times R. Remember, cover up the E, and that equation is I times R. Okay, so I'm going to take that current that I already have, and I'm going to multiply it times this resistance value, and that will give me my voltage. Now, I left that quantity in the calculator over here. And so now all I have to do is multiply by 1.2K. So in my case, that's going to be 1200. And that'll give me my voltage drop. Okay, so my voltage drop will be 2.105 volts. 2.105 volts. Okay. And remember, always with watts, amps, and volts to capitalize the letter. And since this is the same resistor, see, I have the same current and the same resistor, I know that I have that voltage there. Okay. Now, I've got a couple choices here. I could go back to the current that I originally started with, or I know three of the four voltages in this column. So I could just take this value here, and I could multiply it times 2, and this quantity right here would equal those two added together, right? So now all I want to do is subtract that from my 10 volts, okay? So if I subtract 10 volts, it'll give me a negative number. But if I ignore the negative sign, then I know that the answer will be 5.789 volts. 5.789 volts. Now I can check my answer here. It looks like I'm going to be off by 1,000th here. So 2.105 plus 2.105 plus 5.789 is going to equal 9.999. Okay, that is close enough for your answers. Don't worry about being off by 1,000th there. And that just has to do with rounding and that sort of thing. Okay, so now we have our voltages. We can use those voltages to calculate our power over here. Let's see if I can find a good spot for this. About right there. Okay, so I'm going to take my 2.105 and multiply that times my 1.754 milliamps. Now I actually have to put that in as 0.001754. You don't have to do that. You can just use your engineering notation in your calculator. And that gets me 3.673 milliwatts. 3.673 milliwatts. Okay? And if that is there, then I also know that it is here. Okay? So I have those two wattages, and then I'm going to take my 5.789 volts times my 0.001754 amps, because when I move the decimal point like that, it's amps again. In your case, you probably type in 1.754 milli. Okay, and that's going to get me that wattage. And so that would be 1, 2, 3. So that would be 10.154 milliwatts. 10.154 watts. Now I can do a little just quick check in my head. This happens to be pretty close to 1/3 of this. So if I have this tripled, it should be pretty close to that, and it is, okay? So that gives me a little sanity check. And then we're going to go ahead and add these together. So I'm going to take my, now here, because I'm going to be milli, and then I'm going to wind up as milli, I don't have to do my decimal point moving. So I'm going to say 3.673 plus 3.673 plus 10.154. If I add all those together, since they're all milliwatts, I know that I'm going to wind up with milliwatts, and I get 17.5 milliwatts. Okay, so 17.5 milliwatts. Okay, so let's check that against our givens. So we know that 10 volts was given to us, and we know that hopefully we can add these together and get the correct answer. So the 5.7 k ohms has a high likelihood that we did that correctly. So all we have to do is square 10. So 10 squared, and then divide that by my 5.7 k, which in my case is 5,700. That's going to equal this decimal number in watts. But to convert it to milliwatts, I go 1, 2, 3, and it would be 7.5, and it goes on 4, 3. But that is our check to make sure that the sum here and the calculating it across are going to be equal or somewhat equal, very close to each other. So that lets me know that my currents are calculated properly, and my voltages over here were calculated properly. Okay, so there is our calculations that we would do on the front of the sheet. Okay, let's go down here, and we're going to build the circuit. Okay, so in this particular circuit, we're going to actually just go to every circuit. So here you just want to type everycircuit.com. And we are going to just click on this available in Chrome because I'm using Chrome. It's thinking. Okay, so it goes through all of this. You could actually just click on I will sign up later. Okay, you don't have to worry about signing up. You don't need an account. It'll pull up a fancy circuit here that we don't really even need to worry about right now. Okay, it makes a lot of pretty colors. We want to go up here and click on new circuit. Okay, and so you will be left with this black screen, and we're going to go ahead and build our circuit. Okay, so first we want our power source, so we just click on the power source, and then we can drag this down and move it to where we want. Okay, and our power source was 10 volts. So if you click on this and then you hit this monkey wrench, you can rotate this around to where we get to 10 volts. Boom, there we go, 10 volts. So we have our 10 volt source. Okay, so now we had 3 resistors. So I'm going to click this 3 times, and we have our 3 resistors, and we want those in line. So I'm just holding down the left click button and moving these. Okay, so I have those in series. Now the way this works is you have to have ground connected to your circuit. So I'm going to move this ground. You have to have the whole thing highlighted before you can move it. And I'm going to move it till it's down there at the bottom. Okay, and then the circuit will work. If you do not connect that ground, it will not work in this software. So just be wary of that. So now to connect dots, all you have to do is click the first dot and then click the second one, and it'll draw a line there for you. So click the first dot, and I'm just going to click over here, and we have our components all in series. All we have to do is change our values. Okay, so this is 1.2. So again, hit the wrench, and we want 1.2. You could just hit this plus sign here if you want to move it to the exact value. Okay, so there's 1.2 ohms, and then we're going to click this one, and we're going to come around to 1.2 ohms here, and then this one was I believe it was 3.3. So I'm going to use this to kind of get me close, and then hit the plus sign to get to 3.3. Okay, so now we have our circuit. So come back over here. If I remembered everything correctly, 10 volts, 1.2 k ohms, 1.2 k ohms, 3 ohms. Okay, so it says to build the circuit. We just did that virtually, and now we want to take our measurements. So we know that these are all going to work out perfectly. So if you want, you can just write the answers that we calculated up here. I'm just going to copy and paste them down here. So on Inside Rankin, you would just enter these same answers in here. Okay, we're just doing this virtually because of COVID restrictions and those sorts of things. Okay, so what we're really trying to do is answer these questions, because these evaluation questions are really important, because it helps me understand whether the student really understood what they did in this lab or not. So what we're going to do is we're going to come over here, and we're going to virtually energize this circuit. So we have it all built. Hopefully yours looks like this. And then see this little triangle here? It's meant to be like the play symbol. Okay, and you should have something that looks like this. You can use the scroll wheel to zoom in and out. Unfortunately, the zoom, at least on my computer, is very coarse. And so I think maybe that might help. No, not really. So we're going to have to zoom out here a little bit. Hopefully you can see this well enough at this level. Okay. So what this is showing us is total circuit current is 1.75 milliamps. Okay, what do we calculate? We calculated 1.754 milliamps. Okay, so that's at least showing us that our calculation is appropriate, and that's the current that the power supply is supplying. It also happens to be the exact same current that flows through each and every one of these components. Okay, and then if you notice, if you've watched the More Series Circuits PowerPoint, or gone through that PowerPoint, or watched the video, these are our reference point voltage drops. Of course, up here, this is from here to ground. From this point to this ground symbol is 10 volts, and that makes sense because we have a 10 volt supply. This voltage right here is showing us from this point down here, and then this voltage right here is showing us from this point down here. Now we actually have a virtual meter that we can use. We're going to add that in here. So I'm going to click this V, and I have a voltmeter now. And whenever you add any of these components, it automatically stops our animation. And we'll be able to take our readings, our individual readings, to make sure that we have our calculations appropriate. Okay, so I'm going to come down here, and I'm going to hit the play symbol again, and I'm going to get a voltage reading, and it's going to be 2.11 volts. Okay, so we're going to come over here, and it's 2.105, which they rounded up to 2.11 volts. So that is appropriate. Now, if we have that voltage drop here, I can go ahead and let's see if it'll let me move this. No, I think I have to stop. So you have to hit the pause button here, and then we're going to delete this, and I'm going to move this down here. And I don't like it that it makes that whole thing be deleted, but okay. So then here comes to there, that comes to there, and we'll prove out that those should be the same voltage. And this again says 2.11 volts. I'll zoom in just so you can see that reading there. Okay. So 2.11 volts there. And now I'm going to pause and we will eliminate these connections. And we'll move this down. And then we'll measure across here. And hit play again. Okay, and there's my 5.79 volts. So we look over here, 5.789 is what we calculated. They rounded it up to 5.79 volts there. Okay, so that is our lab for measuring our voltages. Okay, so first question, it says, do the measured values and the calculated values match? Well, of course they did, because we're working in a perfect world. But imagine that you're on your circuit board and you would have components that have tolerances. We know that our resistors aren't going to be these perfect values. Maybe we don't get exactly 10.00 volts. So we are going to say no here. Okay, there's no such thing as perfect components. If the measurements are not the same as those calculated, what could be the possible cause? Okay, so I want you to think about this. Variances in the resistor based on their tolerance and their range. Yep. Could not get this power supply to equal exactly the required voltage. Well, that could be a factor. Possible issues with meter reading. Okay, so maybe the place where you're taking a reading with your meter would be, the wire would be rusty. Maybe your leads are not making the greatest contact. So the answer here would be all of the above. Okay. After performing your measurements, explain the characteristics of a voltage series circuit. Okay, so these are the ones that I want you to answer on your own. Okay, so you can go through and experiment with your circuit over here in every circuit, and you could manipulate some components to see if increasing and decreasing resistance values, those sorts of things. That's the beauty of this. You don't actually have to dig through your bag and find all of those things. Now, since we're not using a login or anything, as soon as you leave this screen, your circuit's gone, but you don't really need to save these. You can see how easy it is to build them and how easy it is to get measurements and those sorts of things, that it's not very time consuming. So don't worry about not being able to save those. You can apparently get this on your phone as well. I always use it on the computer and never use it on the phone, but there is ways to do it on at least an iOS phone. I believe it might be on the Android as well, but check that out and see if I'm correct. Okay, so that concludes our lab. I hope that was helpful, and we'll see you in the next video.